Okay. So what we're going to be talking about today is going to be atomic theory, or the history of an atom. And so what geeks me out and what I think is so cool is that you cannot see atoms. You can't. We don't have technology that lets us see them yet. And so everything that we know is based on experimentation. So that's kind of the first little bit here. So everything we know about them is from experimentation. And what's cool is, so as time goes on, we learn more, we improve our technology, and then our improved technology improve our concept of things we know, and so forth. It's a kind of a cool cycle that happens between technology and science. And so with our current model, it's not just one dude who proposed, hey, this is what an atom is. It's actually, it comes from the contributions from many scientists. And so we're going to talk about what some of those contributions are. And so the atom has been developing and theorized since 500 BC. So it's been a long time coming. And originally it started just from what's called a thought experiment. So just genuinely using your brain to think about the concept of what's the smallest particle. And so what we call the atom, so that was defined as the smallest indivisible particle of matter. And so how we got, or how Democritus got to this point was using, like I said, a thought experiment. So he thought, okay, take a grain of sand. If you were to cut that grain of sand in half, and then cut that half in half again, and then cut it in half again, and again, and again, at some point you're not gonna be able to cut that small little piece up in half again. Let's call that an atom. That's the smallest, most indivisible piece of particle of matter. And so, like I said, kind of summarizing what I just said out loud, based on thought experiment, cutting sand in half over and over. All right, I am going to shut this. Okay. And so it took thousands of years. Is that green hard to read? Okay. If that ever happens, speak up. Totally understandable. Let's try this. That better? Okay. Okay, so thousands of years have passed, and now we come on to John Dalton. And so what he did is he didn't necessarily change how we think about a particle. He just kind of gave more definitions to atomic theory. And so again, kind of stating, number one summarizes that all matter is made of chemically indivisible particles that we call atoms. And so what he now goes on to further define is that atoms of the same element are identical, and then atoms of different elements are different from those from any other elements. So because I'm a visual person, if you look over to this first little section here, what you see is that this says atoms of element A they are all identical to each other. Well, atoms of element B are all identical to each other, but atoms of A are different than atoms of B. And so I had a really great question during first hour. Well, do atoms have different sizes like these do? And the answer is yes, most definitely. Atomic radius is something that we'll talk about later on, but that was an awesome question. Are there any other questions before I move on? Okay, 3. So talking about atoms of different elements, well, they can either physically mix or they can chemically combine. Is there a question? And so how they combine is in simple whole number ratios. And so this isn't unfamiliar. We talked about in chapter 2 how atoms can physically mix, make mixtures. We talked about hetero and homogeneous mixtures. And then we also talked about how they can chemically combine to create compounds. So this concept shouldn't be new. But again, looking over to this little picture guide here is just summarizing what a mixture looks like versus what a compound would look like visually, and the fact that these atoms can do both mix physically and combine chemically. Any questions before we move on from here? I know, super exciting stuff today, guys. Don't worry, I have a demo for you later. Okay, and so chemical reactions, now this involves the rearrangement of atoms. And again, number 4 isn't a new concept either. What it's saying is that no new atoms are formed or destroyed. And so that's what this picture here is to represent, is that we start with one molecule and we form 2, but if we look at the atoms, do we still have 1 blue atom? Yup. Do we still have 1 pink one? Yup. 3 yellow ones? Yup. Nothing was created or destroyed. Any questions about those 4 parts of Dalton's atomic theory? Sweetness. Okay. And so just a quick summary of talking about what they thought, or Dalton thought an atom was like, is that they're tiny, indestructible, and that they have no internal structure. And what I mean by that is that there aren't any particles that make up an atom. At least that's what they thought Dalton's theory was, is that the atom is the smallest particle. There's nothing that goes into the atom. But that differs than what we know today, right? What go into atoms? Protons, neutrons, electrons. So, but at this point in time, they don't know about those. So they just think an atom is an atom. That's what it means to have no internal structure. Okay, so flipping over. So now we get to talk about the cathode ray tube. And so I'm gonna try, actually, we'll do this. All right, so to pick up where we left off here is, so we talked about Thomson's experiment with the cathode ray. What it proved was the existence of negative particles, right? That's what we decided, which what we call today are electrons. And so the idea of electrons didn't exist until Thomson discovered them. And so this changed atomic theory in the sense that now that we know that there are something that can be plucked off from pure atoms that are charged versus just the neutral atom, well, now we have subatomic particles. So this is the first introduction of subatomic particles, and how he decided to model the atom is how having a spherical cloud of positive charge. So we haven't quite talked about protons yet, but we know that electrons exist and that they're uniform throughout this spherical charge of positive. And so what he called it is the plum pudding model. Has anyone ever seen or eaten plum pudding? Didn't think so. This is a pretty outdated reference as it comes from the late 1800s. So what I like to compare it to is a chocolate chip cookie. Because what you can think of is the batter of the cookie being the positive charge, but then think of the chocolate chips as the electrons that are mixed throughout the cookie. Any questions on how this changed atomic theory? Okay. So then we need to talk about Rutherford. And so Rutherford was actually a student of J.J. Thomson. He believed in the plum pudding model, but his experiment that actually pushed our discoveries of atomic structure a little bit further. And so what he's famous for is his gold foil experiment. And so I'm going to fill in these blanks as I'm kind of talking about the experiment that's pictured above. But it used radioactive uranium, so that would be like sitting here in this lead box. And what that emitted is a beam of alpha particles. And so these particles, all you need to know about alpha particles is that they're positively charged and they're heavy. And so this beam is aimed here at this piece of gold foil. And around it is this detector screen, which glows because it's a fluorescent detection screen when it's hit with the particles. And so I have a video to show you guys as well. And so to summarize what Rutherford saw, well, he saw that most of the alpha particles went straight through, but some were deflected. And so now, because this didn't fit what he assumed would happen with Thomson's model, this means now he has to propose what he thinks. And so this is the first time ever that a nucleus is proposed. And so in our case, the nucleus that Rutherford is talking about is a small, dense, and it's positively charged. And this is the conclusion he got because of the fact that these positively charged particles were deflected. Because remember, if it's the same charge, that's going to be deflected. But because most of these particles went through, that means the atom is mostly empty space. And lastly, he theorized that the electrons, because he knows electrons exist, must just be orbiting around the nucleus. So this is what I have for your lecture.